All right, here's another example, factorial. So what is factorial? In math, it's written with 3 followed by an exclamation sign. I'm using 3 as an example. So any number here, positive number with a exclamation, means that number times 1 less times 1 less. So consecutive integers multiplied, okay, from some number n up to and including 1. So it should be a positive number. That's why we have the precondition here saying n is positive. It's, well, 0 or more. We could also use 0. And strangely enough, in math, 0 factorial is 1. Okay, there's a proof for that. That's beyond what we're doing, but 0 factorial is 1. So 1 factorial is also 1. So those are going to be our base case. Hope you're getting the picture here. Otherwise, we're returning n times 1 less, which is literally what you're seeing here. So this is pretty much self-explanatory. You can look at this and see this immediately. So if I put a 3 in, it's going to go 3 times factorial of 2, and 2 comes back, and so on. The one we're going to do, though, is factorial of 5, which is 120. This is 120. So let's see how this works. 5 comes in. It's not a 0. It's not a 1. Push onto the stack. 5 times factorial 4. Then 4 comes back. It's not a 0. It's not a 1. Push onto the stack. 4 times factorial 3. Then 3 pushes 3 times factorial 2. Then 2 pushes 2 times factorial 1. Remember, this is upside down. This is actually at the top. Since we hit the base case and we're at the top and it was reachable, time to pop off the stack. What is factorial 1? Well, you already said the base case. It said it's a 1. So it returns a 1. 1 times 2 is 2. Factorial 2 is 2. 2 times 3 is 6. Factorial 3 is 6. 6 times 4, 24. Factorial 4 is 24. And 24 times 5, 120. So factorial 5 is 120. Well, there's something I did not say for all the examples going so far. I didn't stress it. I mean, it's obvious, but I didn't stress it, so I'm going to stress it here. A simpler version of itself. That's crucial. See, what it means is to do factorial 2, we need factorial 1. A simpler version of 2 is factorial 1. A simpler version of factorial 3 is factorial 2. This is the simplest version, hence the base case. Let that one sink in. So all I'm doing here is I'm doing the same thing over and over with a simpler version, right? I start off with a 5, it then went to a 4, then it goes to a 3, getting smaller and smaller and smaller until it gets to the smallest. And then this is finished. I'm going to run this and see that factorial 5 is actually 120. Slide this over. There we go. 120. Let's check one more before we wrap this up. Let me do factorial 3. See what that gives me. So we got to check. This is 1 times 2, which is 2. 2 times 3, which is 6. Better give me a 6, otherwise something's wrong. Voila, got a 6. So factorial is working. Obviously, again, we could overflow the stack. We won't overflow the stack. For most of your questions, the stack will not overflow. It'll be something that actually is reachable. Factorial, just like the sum or the Fibonacci, is recursive. I want to say one more thing before we wrap this up, though. You realize the recursion is small, like very little code, okay? Very concise code. But the stack is actually very much complicated because you got to think about how the stack is being affected by this very little code. So don't let the small size of code think that very little is happening. No, that's not true. As a matter of fact, we consider recursion to be expensive in terms of memory. This is happening in RAM. Hope you know what RAM means. This is happening all in RAM, so that's where the stack can definitely overflow. That's it.